watching Explore Science. In this video, we are going to begin the general organic chemistry. And to get started, we need to first of all know what is hybridization, the sigma pi bonds. So this is what we are going to cover in this video, the concept of hybridization and the sigma pi bonds. So what is hybridization? Intermixing of atomic orbitals of slightly different energies. So first of all, you need to know about the electronic configuration. How shells are different from the orbitals. You must know that the main energy state is known as the shell. And in the shell, there are different types of orbitals such as s orbital, p orbital, d orbital, f orbital. So since we are taking in this video the hydrocarbons or the organic compounds, we are going to study about s and p orbitals only. So let us see what is hybridization. Redistribution of the energy of orbitals of individual atoms to give orbitals of equivalent energy happens when two atomic orbitals combine to form hybrid orbital in a molecule. This process is called hybridization. The new orbitals thus formed are known as hybrid orbitals. So the hybrid orbitals are more stable in a molecule and they are at a lesser energy than the individual orbitals. Okay, so the types here we are going to study is SP hybridization, SP2 hybridization and SP3 hybridization. So let us see what is SP hybridization. It is the mixing of one s orbital and one p orbital of equal energy to give. Equal means that the difference is negligible. There would be some difference, but it is negligible. So we say that they are of equal energy to give new hybrid orbital known as a sp hybridized orbital. Sp hybridization is also called diagonal hybridization. And we can see that how much s character and how much p character is there in this type of hybridization. Since there is one s orbital and one p orbital, so there is 50% s character and 50% p character. And the bond angle, you can see in the figure, its geometry, the bond angle is 180 degree. And its example is carbon containing triple bond. For example, ethine C2H2. So there is triple bond in ethine, means you are taking alkynes here. Okay. So let's come to SP2 hybridization. It is also called trigonal hybridization. Why it is trigonal hybridization? Three orbitals are there. Okay. So one s orbital and two p orbitals of equal energy to give a new hybrid orbital, and those new hybridized orbitals are known as sp2. A mixture of s and p orbital formed in trigonal symmetry is maintained at 120 degrees Celsius. So the bond angle in sp2 hybridization is 120 degree. All the three hybrid orbitals remain in one plane and make an angle of 120 degree. So you can say that it has planar geometry. Okay. Each of the hybrid orbitals formed has 33.33% s character and 66.66 p character. Because there are two p orbitals that are taking part and only one s orbital, so that is why this is the variation in the s and p character. P is double of the s character. The molecules in which the central atom is linked to three atoms and is sp2 hybridized have a triangular planar shape. Already I have told that. So you can see in the figure here, the example we have taken is alkene ethylene C2H4 with double bond carbon-carbon atoms. Okay. So let's move on to SP3 hybridization. So this is formed by intermixing of 4 orbitals, 1 from S and 3 of the p orbitals. Okay, and they are directed towards 4 corners of a regular tetrahedron and make an angle of 109 degree and 28 minutes with one another. The angle between the SP3 hybridized orbitals is 109.28. Each SP3 hybrid orbital has 25%. Now you see there are 4 orbitals and only one orbital is from the S. So there is 25% S character whereas 75% P character. And example of this type are the alkanes, and here we have taken the ethane or methane you can take. Okay. So next topic here we are covering is the sigma and pi bonds. First we need to understand what is the difference between these sigma and pi bonds. What kind of overlap make this sigma and pi bonds? So let us see. Sigma bond are formed with the axial overlap, whereas pi bonds are formed with the sidewise overlap. And overlap of what? It is the overlap of the orbitals. Okay. Next point we see that it is the end-to-end overlap, whereas pi bond is obviously when it is sidewise overlap, so it is lateral overlap. Then sigma bond are strong while the pi bonds are weak. It means that rotation is possible across the pi bond. Large overlapping area in sigma bond, hence they are strong, and the area of overlapping in pi bonds is small, so it is the weak bond. Sigma bonds are formed first when atoms interact. It means that if there is one bond between two atoms, that is a sigma bond and there is no pi bond. But pi bonds between two atoms are formed after sigma bonds are formed between them. It means that if we are taking alkenes or alkynes, in case of alkenes, the first bond formed is sigma and the second bond formed is pi bond. So there is one sigma bond and one pi bond. Whereas in ethyne or alkynes, there are two pi bonds after one sigma had been formed. Okay, so there can be no pi bond until a sigma bond is formed. So you can see the overlap of the orbitals. In the first case you see SS overlap. In the second point you can see PP overlap. So these all overlap are taking on the axial position. Okay, axial overlap. In the next figure you can see the lateral overlap. It is the pi bonds, the green ones. Okay, the green overlap is the lateral overlap, and the sidewise overlap, that is pi bonds. Pi bond formation is occurring with sidewise overlap, and blue color, that is axial overlap, it is the sigma bond. Okay, so you can read also there, a pi bond is formed by sideways overlap of atomic orbitals. This results in electron density above and below the plane. Okay, so whereas in sigma bond overlap is axial, so there is more electron density, but in pi bonds the electron density is above and below the plane of nuclei of the bonding atoms. Here you can see the example. Now you must know that how to calculate sigma and pi bonds. The first figure we have that of cyclopropane. Okay, you don't see any of the double bond there. All the atoms are joined with each other with single bond. It means that there are only sigma bonds. When there is no double bond, there can't be any pi bond. But in case of alkene, in the second figure, that is propene with 3 carbon atoms, you can see that there is one double bond and it is there pointed out. So there is one pi bond, whereas there are 8 sigma bonds. In the next figure, I have a question for you, and I want you to note down these figures and calculate the sigma and pi bonds in each of the figure, and you have to comment below. Okay, I will read your answers and tell you the correct one. So that's all for this video. If you find it is beneficial, you have to subscribe this channel and like this video. Okay, share it with your mates who are in need of these kind of videos, and don't forget to post your queries in the comment box.